Unit 6, Day 2. We are going to discuss quotients of radicals. Again, similar to yesterday, nothing really that new, I don't think. Oh yeah, there is going to be a new part of this today. I'm lying. Okay, couple rules we have to remember. First rule, you're never allowed to have fractions underneath a radical. And what's the other part we have to remember? That's true. Denominator can't equal 0, but I'm talking specifically about radicals. A radical could also not be where? You got it. No radical in the denominator. So if I have a radical in the numerator and a radical in the denominator, and as long as they're not binomials, right? As long as there's no plus or minus signs in either the numerator or the denominator, I can divide them. So radical in the numerator, radical in the denominator, as long as they're not polynomials, they're just monomials, they're not bigger than a monomial, I can divide them. So root 45 divided by root 5 is going to be root 9, and what's the square root of 9? 3. Again, we're just simplifying here, so we're only taking account the positive values. Okay, the other thing we're allowed to do. First, this is illegal. Why is this illegal? We cannot have a fraction under the radical, right? What we are allowed to do, though, is if I have a fraction under a radical, I'm allowed to split it into two, go from one illegal thing to another illegal thing. I can split it into two radicals. So a radical in the numerator, a radical in the denominator. Still not good because you're not allowed to have a radical in the denominator, but this takes care of something. What does it take care of for us? Because they're both what? Perfect squares. Because they're both perfect squares, square root of 100 is 10. Square root of 49 is 7. Can I divide these? Yeah, I can. Radical in the numerator, radical in the denominator, no binomials, nothing bigger than a monomial. I can absolutely divide them. So I'm going to say, okay, well, 18 divided by 6 is 3. So I have root 3. C to the 7th divided by C to the 2nd is C to the 5th. Can I simplify this? Absolutely. Now the 3 stays underneath the radical. But C to the 5th can be, the root of C to the 5th can be simplified. 2 goes into 5 how many times? Twice. So C to the 2nd comes out. Is there a remainder? Yeah, so 1 C is left on the inside. If I'm going too fast, just let me know. So for number 4, are they still monomials here? Yeah, there's no plus or minus sign, so we're still good. I can simplify the coefficients and I can simplify the radicals. It's all good. The only time things change is when I add a plus or minus sign. Then it makes things a little complicated. But 8 over 6, can't that reduce to 4/3? And then 12x to the 3rd divided by 2x is going to give us the root of 6x to the 2nd. Is that my final answer? No, why not? I'm sorry? Good. X to the second is a perfect square, right? Square root of x to the second is x. So we are 4x root 6 all over 3. Oh, hold on. Now let's talk about rationalizing the denominator. You guys should have spent a decent amount of time on this in Algebra 1 and in geometry last year. Okay, what makes this illegal? What's wrong with it? Excellent. You're not allowed to have a fraction underneath the radical. So we're going to go from one illegal thing to another illegal thing. I'm going to split this into the root of 2 over the root of 5. Okay, now I've turned it into something different illegal because you're not allowed to have a radical in the denominator either. Are either of these perfect squares? No. So now what we need to do is we need to figure out how to fix this, how to get a radical out of the denominator. Who remembers what do you multiply a radical by to get it to be a whole number? Ariana? Itself. You multiply a radical by itself to get it to be a whole number. So what I'm going to do, I know it's okay to have a radical in the numerator. I'm just not allowed to have a radical in the denominator. So I'm going to multiply top and bottom by the root of 5. And when you multiply the top and bottom by the same thing, it's like my multiplying root 5 over root 5. Isn't that just one whole, right? Anything divided by itself is 1. So I'm really not changing the value because I'm multiplying numerator and denominator by the same thing. So now I'm going to have in my numerator root 2 times root 5 is root 10. Root 5 times root 5 is whole number 5. Can I simplify root 10 divided by 5 and get root 2? Why not? We were dividing before. How come I'm not allowed to divide this? David?
Both numbers aren't under a radical.
Excellent. They're not both radicals. One's a radical, one's a whole number. You can't divide them. Can I simplify root 10? There's no pairs there. We can't simplify. So this is our simplified version. Okay, so we have 9 times the root of 5x over the root of 24x to the 4th y to the 3rd. We have a few options here. There's a couple different choices of how you want to proceed, and they'll all get you the same answer. You could decide, okay, I just want to rationalize right away and multiply everything by the root of 24x to the 4th y to the 3rd. I'm dealing with slightly bigger numbers. We can simplify that denominator and then rationalize. What do you guys want to do? Simplify, then rationalize? Okay. So I'm leaving the numerator the same, 9 times the root of 5x. In the denominator, we have 24. Isn't 24 4 and 6? And then 4 is 2 and 2. So we're going to have 2 root 6. Square root of x to the 4th is x to the 2nd. Square root of y to the 3rd, isn't that y root y? Can I leave it like this? No. I'm going to look at my denominator, though. Is it still a monomial? Yeah, it's still a monomial. There's no plus or minus sign, so we're good to do what we've been doing. I need to get the radical out of it. I just need to get the radical out of it. So I'm not going to multiply by that whole 2x squared y root 6y. I only need to multiply by 6y, root 6y. So we're going to multiply the bottom by root 6y, and we're going to multiply the top by root 6y. So in our numerator, we are going to get 9, and then we just multiply the radicals. 5x times 6y, isn't that 30xy? Can I simplify a 30xy? 15 and 2, no pairs, right? xy, no pairs. In our denominator, now I'm going to have 2x squared y times 6y. Can I make that simpler? Absolutely. This becomes 9 root 30xy, and then we're going to have 12x squared y squared. Oh, sorry, not done. Why am I not done? 9 and 12, you got it. So now we're going to divide by 3. So we're going to have 3 root 30xy, and then we'll have 4x squared y squared. Are we ready to step it up a little bit now? Yeah? We ready to graduate a little? Are you scared to graduate? Okay, so I have t over the root of 1 minus t squared plus the root of 1 minus t squared over t. Is this an equation? No, this is not an equation. Since it's not an equation, what must we create? I heard it. Common denominator. If it were an equation, wouldn't we want to eliminate the denominator? If it were an equation, we'd want to eliminate the denominator. But since it's not an equation, we need to create a common denominator. I do not want you creating a common denominator without first rationalizing, right? There's something illegal here. We're not going to create an illegal denominator. We want to rationalize first, get rid of that illegal denominator, and then create a common denominator. So this is the root of 1 minus t squared. Can I just multiply it by itself to get rid of the radical? So I'm going to multiply the bottom by the root of 1 minus t squared and the top by the root of 1 minus t squared. So now we'll have t times the root of 1 minus t squared all over 1 minus t squared plus the root of 1 minus t squared over t. It's like nothing ever goes away in this class, right? Like you thought we were past this, but we're not. Before I choose a common denominator, what do you think I'm going to tell you to do to the denominators? I mean, I guess in this scenario, we can leave it as 1 minus t squared, or we can factor it, right? We could have factored. It's okay. In this scenario, are we okay leaving it as 1 minus t squared? Yeah. So we'll leave it as 1 minus t squared. What's our common denominator? T times 1 minus t squared. T times 1 minus t squared. So in the first fraction, what am I going to multiply top and bottom by? T. Do we agree that's going to be a t squared root 1 minus t squared? Yes, no, maybe. All right, and in the second fraction, what am I going to multiply by? 1 minus t squared. So then we're going to have the quantity of 1 minus t squared times the root of 1 minus t squared. All right, now that we have the same denominator, can we add? Absolutely. So we're going to keep our denominator, which is t times 1 minus t squared, and then we're going to add our numerators. So this is going to be t squared plus 1 minus t squared times the root of 1 minus t squared. We are not done. Why are we not done here? Look at that numerator. David.
Distribute in positive and then the t squares would cancel.
Okay, you got it. So right now,
Would there be a parentheses?
what happened?
Here's t squared and then 1 minus t squared.
Yeah,
Did I do something wrong?
there should be a parentheses. Because
So otherwise
T
it's
squared. Oh, I lost my, I just didn't write it down. Sorry, hold on.
You can just put a parentheses.
No, I wanted to write it exactly as it was. I just forgot to copy this part down. 1 minus t squared plus 1 minus t squared root. There we go. Okay, so right now, what can we do here? T squared plus the root of 1 minus t squared plus the quantity of 1 minus t squared times the root of 1 minus t squared. What is there here?
They're common factors.
They have a GCF, exactly. We can pull out a GCF of what? Root 1 minus t squared, you got it. And then I'm going to be left with t squared plus 1 minus t squared all over t times 1 minus t squared. What happens with the t squareds? They cancel. So this is going to leave us. Did I mess something up here? We're good? Are we sure? Hold on. T squared, I pulled that out. 1 minus, yeah, we're good. Okay, so that's going to leave us with the root of 1 minus t squared plus 1 all over times 1, sorry, all over t times 1 minus t squared. Do we need that times 1? 1 times anything is 1. So we're going to have 1 minus t squared over t times 1 minus t squared. Can I factor this denominator? Yeah, would it help us if I factored it? No, it wouldn't help if I factored it. So I would leave it like that. If you chose to factor it, is that okay? Yeah. All right, ready to try another one similar to this? Do you want to try this one on your own?
Yes.
Okay. Hey, what do I tell you to do before you decide on a common denominator? What must you do? Rationalize the denominators. Before you choose a common denominator, you must rationalize the denominators. This one's a little hard. I'm curious to see how you do with it. Ready? No, yes, maybe, no. Okay. All right, let's list some answers we got. Curious to see. All right, tell me an answer you got. David, what'd you get?
2 root y to the 4th minus 1 over y squared minus 1.
Over y squared minus 1? All right, who has a different answer? Simon.
2 times the square root of y squared plus 1.
Hold on. Say it one more time.
This 2 times the square root of, in parentheses, y squared plus 1, and in parentheses, y squared minus 1, over y squared plus 1 times y squared minus 1. Both of these. Divide both of these.
Okay, did anybody get anything different?
We got the same.
I got the same thing as the first one, except it was y4 minus 1 on the bottom.
You all realize this and this are the same, right? Same. All right, did anybody get anything different? No? How many people got this first answer? How many people got the second answer? How many people got the third answer? All right, well, second or third answer, you're good, you win. They're both the same. Let's do this. Arish, I'm shocked. You copied Chris. Why would you do such a thing? You got lost? Okay, so the first thing we're going to do is rationalize. So in the first fraction, I'm going to multiply by the root of y squared minus 1. So we have the root of y squared plus 1 times the root of y squared minus 1. So that leaves us with y squared minus 1 in the denominator. Then in the second fraction, I'm going to multiply by the root of y squared plus 1. So we have y squared plus 1 times the root of y squared minus 1 all over y squared plus 1. Do we agree our common denominator will now be y squared minus 1 times y squared plus 1? Hey, if you wanted to factor it, you could have the first one, but it's not going to help you. That y squared minus 1 could be factored, but it wouldn't end up helping you. So in the second, we have y squared minus 1, y squared plus 1. So in the first fraction, do we all agree we're multiplying by the quantity of y squared plus 1 numerator and the denominator? So in my numerator, I'm now going to have y squared plus 1 times, now I'm going to multiply, I'll hold off right now, actually. Well, does it matter? It doesn't matter. I can multiply these. Y squared minus y to the 4th minus 1. Well, I guess I should do it. Did you guys leave it like these two separate ones, or did you multiply it? You multiply it. It doesn't matter. It all ends up working out. All right. In the second one, we're going to multiply the quantity of y squared minus 1 times the root of y squared, y to the 4th minus 1. All right. Now that we have our common denominators, well, I can multiply this now, right? Isn't this y to the 4th minus 1? And in our numerator, I'm going to get quantity of y squared plus 1 root y to the 4th minus 1 minus the quantity of y squared minus 1 root y to the fourth minus 1. Can I pull out a root of y to the fourth minus 1 here? Look, there's our minus sign. Look to the left of the minus sign. Look to the right of the minus sign. Is there a common factor? Yes, the root of y to the fourth minus 1. I think that's what might have stumped people at this point if you got stumped. So we're going to pull out a y to the fourth minus 1, and then we're left with y squared plus 1 minus parentheses y squared minus 1.
There's no.
What do you mean there's no what?
Or you have to add another parentheses.
Did I add something wrong?
You
Oh, here. There we go. Okay, so now we're going to have the all over y to the fourth minus 1. So now we have root y to the fourth minus 1. And then in the brackets, we're going to have y squared plus 1 minus y squared plus 1. The y squareds cancel. So now we're going to have 1 plus 1 is 2. So that's 2 root y to the fourth minus 1 over y to the fourth minus 1. You can factor. If you did factor, that's like what you would have gotten with what Simon got, but it doesn't help, so we can just leave it. All right, we ready to move on? Okay. When you talk about conjugates in like ELA, it's sort of putting things together, a pair of things joined together, right? When we talk about conjugates in math, let me write it out for you. So math conjugates are formed by changing the sign between two terms in a binomial. So an example is x plus y and x minus y. They are considered conjugates. What happens when you end up multiplying conjugates? It turns into a dot. The middle term cancels. When you multiply conjugates, you end up with a dots. The middle terms cancel. All right, so why do we need to know this? Are we ready? What's the problem now? I've created a different problem that we haven't learned to fix yet. So we have a problem with radicals in the denominator, but it's more than just a radical in the denominator because right now our denominator is not just a monomial anymore. What is it? A binomial. So am I allowed to just multiply by the radical? No. So then somebody might say, well, just multiply it all by itself. Don't do this because it's wrong. If you multiply root 15 minus root 10, it might be like, oh, just square it. Well, if you square it, isn't it the same as saying root 15 minus root 10 times root 15 minus root 10? Well, that's going to be FOIL this out. Root 15 times root 15 is 15. Good track, right? Root 15 times root 10 is root 150. Not a good track. Negative root 10 times root 15 is a negative root 150, and negative root 10 times negative root 10 is a positive 10. So we got rid of some radicals, but then created more radicals. Do you agree? So did this ultimately help us by squaring the denominator? No, it doesn't help. So that's not what we need. We need that middle term to cancel out. So we're not going to multiply it by itself. What are we going to multiply it by so the middle term cancels out? Its conjugate. We are going to multiply by its conjugate. So when you multiply by its conjugate, I'll show you what happens. So when you have root 15, plus 10, root 15 minus root 10 times root 15 plus root 10, you don't have to show the multiplication. I'm just showing you. Root 15 times root 15 is 15. Root 15 times root 10 is a positive root 150. Negative root 10 times root 15 is a negative root 150. And root 10 times root 10 is a negative 10. Don't the positive root 150 and the negative root 150 cancel out? So then we're just left with 15 minus 10, which is 5. Isn't that exactly what we wanted? We wanted to get rid of the radical in the denominator. So whenever you have bigger than a monomial, we are going to multiply by its conjugate. Whenever we have a binomial, we are going to multiply by its conjugate. So our new denominator is going to be root 15 times root 15 is 15. Negative root 10 times negative root 10 is a negative 10. How come I could just do that? Just multiply the outer and multiply like the root 15, and root 10, root 10s. How come I just went to that shortcut? Because you know it's a dot, right? So you know the middle term's going to cancel. That's why I'm able to just shortcut and multiply the outer, the outside ones. So then we're going to have 7 times the root of 15 plus the root of 10. This is going to give us 7 times root 15 plus root 10 all over 5. If you want to distribute in that 7, can you? Yes. If you want to leave it out like that, can you? Yes. It doesn't matter. All right, ready for another one? Hey, it doesn't matter if there's only one radical. It doesn't matter. Is it a binomial with at least one radical? Yes. If it's a binomial with at least one radical, what are we going to do? Multiply by its conjugate. If it's a binomial with at least one radical, we are going to multiply by its conjugate. So I'm going to take 5x minus 2 root y. So in our denominator, I'm going to multiply the outers. We're going to get 25x squared. And what's 2 root y times negative 2 root y? Negative, nobody? 4y, you got it. Can we distribute in that 6 root y if you want to? Yes. Do you have to? No. Does anybody want to see me distribute it in? Yeah? Okay. So this would be 30x root y minus 12y all over 25x squared minus 4y. I'm sorry? No, you could have left it like this, or you could have distributed in and gotten this. Either answer is acceptable. Do you all want to try one? Try this one. Don't be scared. You're going to have to FOIL out that numerator. You are going to have to FOIL out that numerator. Who has, do we need more time? All right, who has an answer for me? Well, we're going to list all the answers. I'm curious to see who's got some answers. Claire, what'd you get? Who has a different answer for me? Aditya.
1 minus root 2.
Who has a different answer for me? Navya.
7 minus 3 root 2 over 7.
Who has a different answer for me? Okay, so these two are similar, but one is correct and one is partially correct. In the first one, isn't there a GCF of 7 that we can pull out that will simplify with the denominator? So this will bring you down to this. So this is our final perfect answer. Who wants to see me do this problem? Let's do it. Okay, so do we all agree to start off here, we're multiplying by the conjugate 3 minus root 2? So in our denominator, I'm squaring A, I'm squaring B, we're going to get 9 minus 2. In our numerator, we need to FOIL. 1 times 3 is 3, not 1. 1 times 3 is 3. 1 times negative root 2 is a negative root 2. 2 root 2 times 3 is a negative 6 root 2. Negative 2 root 2 times a negative root 2 is a positive 4. Now we combine our like terms. 3 plus 4 is 7. Negative 1 root 2 minus 6 root 2 is a negative 7 root 2 all over 7. Now we pull out a GCF of 7 because we can simplify. And the 7's cancel, which gives us the 1 minus root 2. Okay. Next one. We're not going to do this one because I need to do the doozy. But I am going to discuss this one with you because I don't want you to become robotic and not think. In this scenario, I know we have to create a common denominator. Do you agree with that? But before we create a common denominator, what must we do? Rationalize. Am I multiplying by conjugates here to rationalize?
No.
No. Why? It's not a radical binomial. It's not a radical plus something else. Do you guys see that? So in this scenario, to rationalize, can I just multiply by the radical itself? Absolutely. I can't stress this enough. Right? This is not multiplying by the conjugate because this is not a radical plus or minus something else. This is just a radical by itself, so just multiplying it by itself will cancel out the radical. Are we okay with that? Similar to the problems we did earlier. All right, I'm just going to write do not multiply by conjugate. All right, we ready for the doozy? Are you scared? You should be.
This is a very big difference.
Okay, why, how, or not how, how is this different from the other problems we've done? It's a trinomial denominator. So we're gonna go with the whole conjugate idea, but it's not gonna work the first time. So we're gonna have to do it twice. So it doesn't matter. We're sort of like grouping things together, considering one A and one B, because you know how we make like an A plus B and an A minus B. Right. So you can group the 5 plus root 3 together and have the minus 2 as the B. So this is sort of your A and then that's your B. Or you can make this your A and this your B. It doesn't matter. It is all horrible. It is all going to be miserable. There's no better option. So let's go ahead and group the two radicals together and have that sort of be our A. So I'm going to take this whole thing and I'm going to multiply it by the root of 5 plus the root of 3, and then what do you think? Plus 2. All right, now we're going off. This is not a squared b squared, right? We can't do that because technically it is trinomial times another trinomial. We have to just triple distribute this out. So I'm going to take over on the side of my paper root 5 plus root 3 minus 2 times root 5 plus root 3 plus 2. And I'm triple distributing this out. Root 5 times root 5 is 5. Root 5 times root 3 is root 15. Root 5 times root 2 is 2 root 5. Then I'm going to use the root 3, and I'm going to have root 3 times root 5 is root 15. Root 3 times root 3 is 3. Root 3 times 2 is 2 root 3. Last one. Negative 2 times root 5 is negative 2 root 5. Negative 2 times 3 is not positive, sorry. Negative 2 root 3. And negative 2 times a positive 2 is a negative 4. So now when we're simplifying, do things cancel out here? Yeah, some things cancel out. What cancels out? Nobody sees things that cancel out? All right, let's go through this. Let's look at our like terms. 5 gets added with the 3, which gets added to the negative 4. So 5 plus 3 is 8, minus 4 is 4. Then we're going to have root 15, and another root 15 is going to give us 2 root 15. Are we good so far? Then I have 2 root 5 and a negative 2 root 5. What happens there? Cancel. Then I have 2 root 3 and a negative 2 root 3, which cancels. Look at that. What did we come down to? A binomial. So now we're going to have, we're not done. We still have the, what was my numerator? 4 root 5? 4 root 5 times root 5 plus root 3 plus 2. That's our numerator, right? And in our denominator is 4 plus 2 root 15. We have to distribute in that. We're going to have to distribute in that numerator. When we distribute in that numerator, we're going to get 4 times 5, which is 20, plus 4 root 3 plus 8 root 5. Did I do something wrong? Oh, no, it's 4 root 15. Sorry, 4 root 15. Y'all are so aggressive. All right, and then our denominator is 4 plus 2 root 15. Am I done? No. What am I going to multiply by now? The conjugate. 4 minus 2 root 15. You can pull out a 2. Do you guys want to do that first? Sure, we can pull out a 2. It's not going to make a difference. It makes it a little smaller? Sure, let's pull out a 2. So if we pull out a 2 in the numerator, we're going to get 10 plus 2 root 15 plus 4 root 5. In our denominator, we'll pull out a 2. We'll get 2 plus root 15. These 2's will cancel. So now we have 10 plus 2 root 15 plus 4 root 5 all over 2 plus root 15. What am I going to multiply by? The conjugate 2 minus root 15. So in our denominator, it's a squared minus b squared, so it's 4 minus 15. In our numerator, can I just give you my simplified version of this? Yeah, I think it's going to be, I don't know, if somebody else did it and got something different, tell me. 6 root 15 plus 20 root 3 minus 8 root 5 plus 10. That's the numerator. Chris, Jason, anybody that usually goes ahead of me? Over negative 11. This is your answer. We just don't have enough time to sit there multiplying it out.
Wait,
Is it wrong?
you mean plus 20?
Plus 20 root 3. Yes, I'm sorry. Okay, so we are done. There is one thing I didn't get to show you, but it will only take me 2 seconds to show you, so we are good on the homework tonight. Oh, except the factoring. Except the factoring. I'd have to show you the factoring tomorrow. Your homework, yeah, no, there is homework. It's a worksheet. Homework is a worksheet. No, the worksheet is mandatory. The 2 worksheets, the textbook pages are optional.
You got 17.